All right, we're going to have a panel discussion now, and the first thing we ought to do is introduce our panel. And Dr. Zurbuchen, would you introduce yourself, please?
Yeah, happy to. I'm Thomas Zurbuchen. People refer to me as Dr. Z because nobody can pronounce Zurbuchen in English. And I'm the head of science at NASA. So as part of the program is the Commercial Lunar Payload Services program, which of course is why we're here, in part.
And sitting right next to Dr. Zurbuchen is NASA Space Technology Associate Administrator James Reuter.
Yes, hello. I run the Space Technology Office for NASA. I've been at NASA actually for about 39 years, so a long time. I've loved every minute of it, and this is one of the more fun jobs I've ever had because I get to come to events like this and see the outstanding work and really invest in a lot of America in the space economy. So it's great to be here.
And of course, we do have to give Ohio equal time. So.
Thanks. Maybe I won't take as much time. So my name is Carlos Garcia-Galan. I'm representing the Glenn Research Center. Right now, I am the manager of the European Service Module Integration Office for the Orion program. Super excited to be here. I've actually spent most of my career at the Johnson Space Center. I've been a flight controller for the space station. I've worked in different jobs in Orion, but Glenn leads the integration, the development of the service module and the integration into the Orion program, and we'll talk about it later, a lot of stuff for Gateway as well. So super excited to meet all of you and talk about the things that we're doing. I'm originally from Spain, so maybe I am going to take extra time. And when I was growing up as a little boy, I just kind of dreamed of working in the space program. And for many, many years to now, we're in an environment that I couldn't even imagine in the past we will be in right now, going back to the moon, thinking about Mars. So I think this is an awesome opportunity to talk about what it takes to get there in the region. Thanks.
Terrific. I want to say this is a particular delight for me because I became chair of the committee that funds NASA at the beginning of last year. And so all of these faces up here were faces on my Zoom screens. And I have never seen them face to face before today. So a real pleasure. Well, we have a number of topics we'd like to cover, and each of you weighing in will be an important thing. The first idea is what coming projects or NASA priorities should these folks know about? What kind of commercial/private company support will you need? How do you get contractors and subcontractors for those needs? And what is a quote-unquote NASA-ready company? Take it away, Dr. Z.
So I'll just do a subset of it because I want to make sure that we don't end up repeating each other. I want to tell you about this morning. So this morning, a small helicopter on Mars flew its 26th time and successfully landed. Actually, it flew over the parachute that got it there and took a movie looking down. So pretty soon you're going to see that in the news. And basically, we'll see, of course, that kind of amazing environment being affected by humans, being explored by humans with questions that are on our minds for, frankly, thousands of years about life itself. The power of science that you talked about is so inspiring. I want to just really tell you that. I also woke up this morning and I looked at the weather forecasts, in part looking at using a spacecraft that was developed at NASA with contractors from around the United States, was launched and is now operated by NOAA, and then used the GPS to go to work, which of course is go to the airport, that is, because again, developed by amazing scientists and kind of professionals in the Department of Defense generally, and frankly looked at the news and saw images by a private company that took images of Russia as yet again, the atrocities that they're unleashing on their neighbors is image from the sky. You cannot hide anymore from the sky right now. So when you talk about this question, what are the opportunities ahead of us? I think there have never been more opportunities for really the commercial sector, whether it is in that kind of more service-based type of contracts that we have. Yesterday, by the way, Congressman, we had the release of the 10-year strategy of planetary sciences, and what we got there is an endorsement of commercial lunar payload services, which basically means that the science community says this is absolutely important and is part of the strategy going forward. So we want astrobotics, we want more astrobotics type of things. And not only do we want to go to the moon with that, we also want to go to Mars with that or other locations, which is what they recommended. Same is true with Earth-based spacecraft and with many of the other programs that we built, both as part of the Artemis program, but also as spacecraft near Earth or to other locations. So the kind of company, kind of the confluence of an amazing entrepreneurial mindset, which John has and others in the state of Pennsylvania, Ohio, West Virginia, together with money that is raised often in the community and the amazing talent that is here is really, I think, where the magic is in this particular region.
Thank you, Dr. James.
Yeah, hi. We have fundamental, as for Space Tech, we have three fundamental goals, objectives of how we invest in. The first one is to develop the truly transformative technologies that really can revolutionize and enable new missions and discoveries for NASA. The second one goes hand in hand with that, and that is our objective is to really drive the U.S. space economy. I think a large number, as we've seen it over and over again, Astrobotic here, and I can name 10 small businesses around the country, just off the top of my head, of when we invest in them, give the innovation there, have our tough challenges trying for them to reach, great things happen, and I think we're seeing it here. And then the final one is to inspire. A large part of what we do is to help the next generation and the entire community go forward. I'll just say there's a number of programs we have and we spanned on our investments from very early concept stages that, good ideas to into laboratory demonstrations and into flight. And we invest all along the way. A company like Astrobotic has received something like 20 small business innovative researchers. They were very creative in how and strategic, I think, in how you applied those to the next level where we do laboratory demonstrations, getting ready for flight, and we have a tipping point program that also has gotten a great deal of use. And the idea behind that is let's find the things that are just on the cusp of really becoming something that can be really valuable, both for a NASA mission and for a commercial value. And it's got to be something where there's skin in the game in both ways. And that's what really helps drive it. We give flexibility, we have skin in the game, and then what comes out of that is almost always good. I will say we have a solicitation that's out right now, we started this program maybe 5 years ago, and we had like 30 applicants, and the amount of money we invested was $20-30 million. Well, the last one we had was $370 million of awards. The one we have right now, we'll see where we go into the awards, but we give them preliminary proposals, so we don't make people have to give out a detailed proposal until they know it's something that we both want to do. And we've gotten well over 200 of those. And all of them have huge leveraging, so we're really excited about it. Now, in terms of what's a NASA-ready company, I've never actually heard that term or haven't really thought about it in those terms. For us, what we want is a company that recognizes a challenge, that has a creative solution for that challenge if it can be proven out, and is going to persevere. It's really hard. Rarely does something go right the first time. I think John mentioned earlier that they had multiple times where they weren't so sure the company was going to still last, especially in those early years where especially it's there. But just don't give up, get creative about it. And, but then also beyond that, honestly, we do hear people say it's a little hard to crack into NASA as we go forward. We're trying to make that easier as we go along. But we do we're doing everything we can to recognize that and broaden our vision. But things like small business innovative research, we have over 700 or so, around 700 awards every year, and so we really do have opportunities as we go forward.
And Carlos.
All right, so I'm going to focus a little bit on Artemis. and emphasize some of the points there. So, what's in front of us right now, literally, with the rocket on the launch pad, is the Orion and the SLS program. I particularly work with the European Service Module, but even for that, there's a bunch of components that the US is providing for them, from the main engines, the auxiliary engines, and valves. So even though those systems are already built and in production, we actually have the pressure vessel for the Artemis 3 mission, which is going to take the first woman to the moon, first person of color, the next man. It's already a Kennedy getting outfitted. So even though those things are in production, there's still opportunities to work with those programs, and there's upgrades coming up, and we're also looking for ways to upgrade the system such as we can reuse them and make it more affordable and sustainable. So that's Orion SLS. After that, we're building the gateway system. Glenn Research Center, for example, is the lead center for the power and propulsion element, which is going to provide electric propulsion for the gateway elements. And then what are we going to do in the gateway? There's going to be many experiments. I mean, Artemis is really a proving ground for technologies that we're going to need, and also building the know-how in logistics and many other things to go to Mars. So for the next decade, not only is the systems that we're building, but also what we're going to be doing with those systems. There's plenty of opportunities for experiments, research, technology that we want to incorporate into that. So, and then after that, lunar surface systems, where we're going to have to learn to live there long periods of time, supply that through logistics. Low Earth orbit is a few hours away. The moon is a few days away. The logistics is complex. And of course, we're trying to learn as much as we know about living in low Earth orbit around the moon so we can then go to Mars, which is months away. So, I mean, I can't even imagine to think the amount of opportunities on the surface of the moon. We're going to need power systems. We're going to need new materials. We're going to have to deal from things from generating power to communications to how to deal with the lunar dust. All of those things are in play right now and are going to be in play for years. So we absolutely need to be prepared, especially in the region, and things like that are just perfect for that. One more thing, we talked about China, we talked about Russia. I go to Europe a lot because we work with our European Space Agency partners on the European Service Module. The space economy is also catching fever over there. So we're going to get competition not just from China and Russia, but many European nations and startups over there. So we really we cannot afford, as congressmen said, we cannot afford not to invest and put our resources in this stuff right now. And then as far as Glenn Research Center, space ready, NASA ready, what we're looking for are, like Jim said, companies that will persevere and do the homework. We have, for example, if you're a small business company, you can log in the website for the small business programs for NASA, and they'll take you through a series of steps that you can do even before their solicitations you're interested in applying. They will have a lot of information on the type of things, government contracting is maybe not the most easy thing to do. So that they'll have the information there. You can do research, you can provide your information, get checked out, and basically be ready for when those opportunities come. Everything is there, and you can just focus on the technology you want to bring forward or the partnerships. And then the last thing I want to mention is a very important point that Jim already brought up, the inspiration part of that. In Orion, like I said, we're about to launch. We can absolutely not afford to use this. We absolutely have to use this opportunity to project what we're doing to the next generations of students and even people entering the workplace right now. What can be more exciting than going back to the moon with people, setting up a shop on the lunar surface? You imagine all those pictures. I mean, I went to high school in the 90s, so I wasn't around for the Apollo program, but I was inspired by all the videos and the stories. I think I've seen every documentary on the Apollo program that's out there. That is what drove me, and then the space shuttle, and then the space station. We're about to have material for decades. I mean, we're talking about launching, maybe next month. All of that is going to be ready at our fingerprints. So I plan to be part of that. We got to inspire other people to be part of that. And companies that are working with us join in that effort too, because we got to inspire people. We got to let everybody know. Every high school here needs to know what companies like Astrobotic are doing in the Pittsburgh region and want to go work for them instead of going somewhere else. Thank you.
Thank you, Carlos. And Justine, you have to help me out here. We have We have three very high-ranking NASA officials here, and people who can hold forth at great length on things about any topic about space. In fact, their ability to hold forth at length is astronomical. When you say you want us to go on for 5 minutes, do you mean each, or do you mean in total? Total, okay. Clarification.
Okay, good clarification.
Let's go to the next slide then. Question is, how is NASA already working in the Keystone region, Pennsylvania, West Virginia, Ohio? Give examples of how our local companies are already playing a role in NASA's human exploration of the moon and Mars. How will the Commercial Lunar Payload Services Initiative allow companies like ours to work with NASA to explore the moon? And can you tell us more about the Lunar Surface Innovation Initiative and Consortium? Carlos, you go first.
All right.
Let's see, 2 minutes and 40 seconds.
Okay, I will cut that. So at Glenn Research Center, we have, we're working with many companies and industries, not only in these space systems, but also in the testing part of the program at the Neil Armstrong Testing Facility. So we're already working with companies like Zen, Astrobotic. We have a PILS payload that is going to go in one of their landers for, photovoltaic research. So I think, but we want to continue outreaching, and we want to continue talking to more people and finding opportunities for us to partner with you on the adventures that are coming forward after that.
James?
Let's see. First of all, in terms of a couple of examples of companies, of course, everybody knows Astrobotic, so we can, set that on its own tier. But I'll just mention a couple others and probably talk about it again later when I talk. But one is Bally Ribbon Mills. This is a small company in Bally, Pennsylvania, I think a little south of Allentown. They've actually been working with the space program for quite a long time. What they do is, their unique capability is the ability to weave materials to create some extraordinary capabilities of it. And so they have this woven thermal protection system, extremely dense material that they can make. And Orion actually uses that for what they call the compression pads. The most critical spot between holding the service module and the crew command together is in these exploding bolts. And and that area then creates a gap that you can't afford to have heat flow through. And so Bally Ribbon's material is used there to absorb the loads, to provide that thermal protection, and then also to take the shock of the pyros when they separate. So it's a great product, a great company.
30 seconds.
30 seconds. I can't see it. So.
Yeah, we can't see
So I'll just do one other one then, and that's pH Matter. Thank you for that. It's in Columbus, Ohio, and they've recently won a couple of awards from us in our last tipping point and our announcement of collaborative opportunities to develop regenerative fuel cells for power and utilize the water on the moon and stuff, and they're doing great work in that, and they're doing a lot of testing as we go forward. There's actually a lot of other companies too, but I'll just stop at those two.
Beautiful. Dr. Zurbuchen.
You need to start my clock. That's less time now. It's all good. It's all good. Don't worry. Look, what I'm going to talk about is the Commercial Lunar Payload Services. Just kind of just talk about that a little bit. We're just starting. John mentioned that this is going to be the first landing. What we're really interested in is changing the business model for how we build spacecraft to one that very much includes services. And so basically, what does the Commercial Lunar Payload Services do? Well, in addition to delivering science payloads, which is why I want to do it, frankly, at roughly 20% of the cost or 10% of the cost of a traditional approach, which is why it's so okay to take more risks, right? Instead of just thinking of that, we also think of it as bringing technologies to a planetary surface. This is the kind of stuff that Jim does over here, or even educational projects to the planetary, to the lunar surface, other planetary surfaces. So for me, that's where I see. I really am interested in that model because it opens up the door without government contracting, kind of at the same level that we normally do, open up the door for new companies to enter the sphere. That's what we're really about, and that's what the model is that we're trying to build here.
And
Good.
as a point of order, I didn't realize the last question on this sheet of Lunar Surface Innovation Initiative, which is something we've started. Is there any chance that I could get a minute to
Sure.
talk that, since I sadly abused my time? What I'll say is back when we established the Artemis program and wanted to go back to the moon and stuff, what we want to do is do this differently from Apollo. Apollo was an awesome program, but it stopped. So we wanted to have it so that we have a sustainable presence on the moon. The way I believe you get sustainable presence is that you engage a broad community. And so the Lunar Surface Innovation Initiative was created by us. Actually, the kickoff was 12 days before COVID. But the kickoff. So what we have there is communicate. It's a ability to communicate and coordinate across the entire community. So we have 600 organizations that participate on a monthly basis, and we have. Anyways, and we have like 6 focus areas that we talk about. Johns Hopkins APL leads it for us. And so it's an idea of bringing everybody together, and the response has been really fantastic. It's a place to share what kind of technologies that we can go pursue and just go forward. So it's really been a fun program. Thank you.
Great. Okay, next slide. How can we grow commercial space potential here in the Keystone region? What are the first steps to get connected to commercial space opportunities? Tell us more about NASA programs like SBIR and STTR. How does NASA help first-time appliers? And how can higher eds and R&D support commercial space potential? Jim, you go first.
Okay, I'll tackle, now that I know I got to read the questions, I'll tackle the SBIR one. Because that's a program that we have, and it's one of our favorite programs because it is really the seed that provides everything else, and a large number of small businesses have really grown from there and really expanded. Our program starts, it's a multi-phase thing. And this is government-wide, actually, for any government that has research and development as part of their responsibility. But for us, our phase 1 is $150,000 to develop a concept. Almost right away after that, if you're selected, you can get a phase 2, which is another $1 million. Phase 1 is 6 months. The phase 2 can be up to 2 years and stuff like that. And then from there, you have the opportunities for post phase 2 awards or a phase 3 award, in which case the advantage for a phase 3 is we don't contribute money anymore, but what you have is a technology that's identified and you have the rights for it. And so we can very quickly negotiate contracts to do more work. The phase 2, there's an extension phase 2 and then there's now we also have up to $2 to $5 million awards for a phase 2. There's a post phase 2 that's about the $3 to $5 million, as well as a commercialization where if you get matching funds, we'll go up to $6 million combined for the two. So that is a great place for us to start as we go through it. And in order to get more information on it, well, if you look on our website, sbr.nasa.gov, you can get all kinds of information of how to get started. And with that, the part of that is it gives you a kind of a roadmap of all the things you can do to go forward with that. And so.
Thanks, Jim. And Carlos, how about you? What are the first steps to get connected to commercial space opportunities?
So I would say the first step is reach out. We have offices at NASA level, and then at the center level, at Glenn, we have a small business office and other offices that will help you kind of understand what's out there right now, and also how to get ready and be NASA ready. So when the solicitations come out, you'll get it automatically. Like I said earlier, there's plenty of opportunities in many, many different fields that are present today. Part of the Artemis and aeronautics We're doing a ton of stuff there, so that the opportunities are there. So reach out, get connected. The right people will talk to you individually about what are the different steps to get ready. And there's stuff to fill out, so you can be, everything can get checked out prior to the opportunity, being present and coming forward. And then, like I said, we're looking not only for straight government contracts that come out, but also partnerships. If you have an idea, you're familiar with something that we're doing, and you think you can contribute, we'd like to also hear from you, whether it's industry or academia, and develop those partnerships.
Beautiful. And Dr. Z.
So I work with a lot of missions. We have 124 or so, and I always thought that before I went to NASA, I was in higher ed. I always thought that the way you build a NASA project is 70% technology and 30% team, and I got it wrong, Congressman. It's backwards. 30% technology, 70% team, and that's precisely why this is such a great region. The universities that you have here, frankly, are the envy of the world. Whether it's here in town, whether it's Penn State, whether it's Pitt, it's other universities that are here. I believe kind of empowering these universities to really create entrepreneurial ecosystems that kick out ideas of the type that John is, and really kind of supercharge them, not only educates that talent that then will be part of that kind of space economy, but also, frankly, creates kind of critical mass that are there. So for me, in the last question there, how can higher ed and R&D support commercial space potential? It's that way, by creating a sense of urgency. There's never been a better time to launch into this activity than right now, and we're open for business. And so are other agencies, and of course also private entities around. So for me, I just really hope that you kind of come together. Not any one of you will do this. John sits here with an amazing company. He himself said he didn't do it alone, and that there is no company that is a single person. There may be one person who always tweets or always speaks, but we all know these companies. It's teams that do that. So I just really believe in that, and the power of this area and the entire Midwest, frankly, to contribute to the important priorities, especially as it also relates to earth science and so many of the things that relate to our climate, to the environment that we so cherish in this region and anywhere else.
Beautiful. Thank you, Dr. Z. It looks like we're moving to audience questions now. And do we have a microphone they can go to? Okay. We have, yep, so raise your hand.
I just noticed that the administrator, Nelson, with the astronaut jacket arrived here, so I just see that.
Here he is.
Yeah.
Don't let him ask any questions. Here's a question back there.
Who had the question?
Go ahead.
Thank you, Congressman. This is a question for you. Big supporter of the space program. Would like to understand what we're doing to fund cleaning up the low orbital space or atmosphere with the space debris as we move forward expanding space.
Oh, definitely interested in that. Gentlemen, you want to address that?
Yeah, that's a great challenge, and you just look at the explosion in satellites in space right now. I think Amazon's deal they announced a couple of weeks ago was 3,200 satellites when you add it all up, on top of the SpaceX consortium, and so and I think of orbital debris, which is of course a multi-agency problem. It's not just NASA, but multiple agencies. But I kind of think of it as a three-pillared orbital debris control. The first pillar is being able to detect what is hazardous, and so that it's there. And we do pretty good up to a certain level, but below that we really can't. There's a large number of particles and stuff that are below the size that we can really detect, but that can cause real harm. The second tier of this, the pillar of this, is to adopt mitigation standards and mitigation attempts, so that when you launch a satellite, by operational control and by design, you can remove the probability of it being a hazard as we go through it. And then the third is the most challenging step, which is active debris remediation. Of what sort of things can you do that can really remove the hazard. That is an extremely tough challenge. And one of the toughest challenges about that is you have the potential to do more harm than good. And so you have to be careful of how you go about it when you go through this. So really right now what we're doing is a lot of the basic fundamental technologies that we're doing is satellite servicing, that sort of stuff, apply to this. And then we're doing some basic research, but really we haven't gone past that.
If you want me, I can add just a couple comments to that. And that has to do that, of course, everything he said, of course, is important. And I really believe there's a big market opening up for these things. And kind of this orbital debris is really an international, kind of a global thing, and nobody really has the right answer right now. I mean, frankly, if I was kind of in the business world right now, in the investment world like I used to be, I would look at those companies. I just think it's such a mega problem. It needs to get solved, and kind of, frankly, innovation is the answer to that challenge, like so often. I also believe, by the way, that one of the contributors that we need to do, and one of the things in the bill that you helped support, is actually trying to look at the lower scale of this. So he's talking about things that are, like this or larger, right? Which, if it hits a spacecraft, it could take you out. If you go to a smaller scale, frankly, it limits the lifetime of spacecraft in low Earth orbit, and we don't really know what it is. So, kind of in this year, the bill that just got passed, we have for the first time, kind of support of really doing measurements there, together, of course, with the natural environment. That's also important, the upper edge of the atmosphere, so to say, which ultimately filters out those systems.
Right. It's a great question and an important one. And obviously, we have a good grasp of the enormity of the problem and the gravity of it. When tiny little pellets in space traveling at hundreds and hundreds of miles an hour, the damage they can do. On behalf of the United States Congress Committee on Appropriations, I can tell you we are ready, willing, and able to fund research into the answers as soon as NASA asks for that money. Other questions? One more question.
Thank you, Congressman. Over here to the right.
Oh, here.
There you go. Big redheaded guy, tough to miss. So just a comment and encouragement. Commercial industry responds to challenges. And I think if you look at the space debris problem as a brownfields cleanup, a community is growing. They have a dump. They realize if they clean the dump up, they can put commercial businesses on there and generate tax revenue, and it cleans up for itself. I would encourage Congress and NASA to look at it as a brownfields reclamation project and say, I'm going to spend $30 billion in the next 10 years to solve this problem, and to get it done, and commercial industry step up and match us or step into the gap. And I think you would find a huge response to that approach, and you'll generate hundreds of billions of dollars of tax revenue 5 years later. So it's just a thought. And then a question, I guess, to the NASA folks. If you were sort of looking out at your roadmap 5 or 10 years from now, where would you be placing your technological bets in your two different divisions?
I'm sure every one of us has a slightly different answer. I would focus on autonomy. On the one hand, kind of the spacecraft that we're building today need to be a lot smarter. There's too many spacecraft out there that need to get out of the way themselves. Also landing on other surfaces, it's autonomy. I think in general, it's just a big space. I think kind of new materials, and especially also some of the 3D printing, whether it's on the ground in space or on the surface of the moon. I just learned about a professor from Penn State who's doing that in her research, right? So for me, I think that kind of material stuff, as we want to build a sustainable presence on the moon and also kind of build structures in space that are kind of transformative relative to where we have been. I think that's a really critical element. So for me, those are the two I would put up front.
Yeah, I'll say assembly in space can be really revolutionary. Break the bounds of the fairing size. of a launch vehicle and stuff. I think additive manufacturing in space can be really essential. You know, we operate a space station and have done so, you know, almost flawlessly, I think, for 20-some years, but we bring up a lot of spares. Well, if we want to go further than low Earth orbit, we can't afford to bring up the spares, so you have to be able to make them when you get there. So I think that's transformative. And I'd also say is I think there's a time for nuclear systems now, fission systems, and I think that can be really revolutionary. I want to get from point A to point B a whole lot faster, so we can go outside this solar system eventually, and so on. And I think nuclear systems can be revolutionary that way.
Carlos?
I won't give you anything specific, but I'll basically put the challenge out there. So what are the things that we're going to need? What are we doing? We're trying to go to Mars. On the way, we're going to the moon, and we're going to spend time on the surface in a sustainable and long-term way. So what are the things that are going to be a challenge for us? As a proving ground, if you think about technology, and a lot of the stuff has been said already as far as nuclear technology, materials, and so forth, but think outside the box. And don't think about just technology that leads to one piece of equipment or something specific. The logistics part he was mentioning, that's a huge problem. So think about what it took for us to get extremely comfortable to live in low Earth orbit, decades of doing what is it going to be to do the same thing, days away from Earth, many thousands of miles, and then what are the things that we really would want to prove before we step forward, like in situ utilization of materials and things like that. What are those things? And we're not the only ones that have the key recipe for that. So think about those things, bring them up, and push them forward. And if those are aligned with the vision of eventually going back to Mars, I think there'll be an opportunity for you.
Thank you, gentlemen. And thank you also for the preamble to that question about the economic opportunities for doing things like cleaning up brownfields. I know about that. I know a lot about that. In fact, I talked about the Infrastructure Investment and Jobs Act, and I was one of the loudest voices urging money in that bill to be devoted to the cleanup of abandoned mine lands, about a third of which are in Pennsylvania. And to talking about the economic opportunities that are reflected in those chances to clean up abandoned mine lands, it's a very important thing. So, look, how about a round of applause for these three terrific NASA experts, Dr. Thomas Zurbuchen, Mr. James Reuter, and Carlos Garcia-Galan. Thank you very much, gentlemen.
Thank you so much for the panelists. Thank you for coming here today. My mind is blown. You have just said 4 of the things that identified the strengths of this region: autonomy, material science, additive manufacturing, and logistics. We're on it. So if I can paraphrase for our group, I heard 3 things. I heard NASA is open for business. I heard the congressman say he will fund it. And maybe.
That's all they want.
And I also heard that the Keystone region will deliver.
Terrific. Thank you.